Hello there, Mr. Sutton here with the Pre-Cal Honors 9-2 Extra Practice number 3 solutions on infinite intuitive limits. For this question, we're going to be answering the following limits questions based off of this graph. So first one, part A, limit as x approaches 3 from the left side. So here's x equals 3. As we come from the left, we are at the y value. We're approaching the y value -1 for that one. And then as we approach 3 from the right side for part B, so here we're coming from the right side, that's up at the y value 3. And now the two-sided limit at 3, well, since we're going to a different place from the left and the right, since these two limits can't agree, we would say does not exist for the two-sided limit. Now f of 3, that's the function value at 3. That's the solid dot, which is at the y value +1. Next, as x approaches -infinity, so as we move to the far left, the y value we're approaching, we're at the whole time because it's a horizontal line, that's going to be -1. And as we move to the far right with x approaching +infinity, we are at the y value +3. On this question, we're going to be using the following graph to answer these limit questions. So first four actually are talking about the behavior of our graph at x equals 2. So left side limit at 2. As we approach 2 from the left side here, we're going to the y value 2. Next, as we approach 2 from the right side, so coming to from the right side here, we're approaching the y value 0. And since the left and the right limit don't agree, the two-sided limit as x approaches 2 does not exist. Function value at 2 is going to be this solid dot up here, which is a y value of 2. Now, x approaching -infinity, as we go to the far left, we're approaching the y value 0. We're approaching the x-axis there, which appears to have a horizontal asymptote. And then as x approaches +infinity, well, it looks like we have a horizontal asymptote as we move to the right at y equals 2. So 2 would be the limit for the right infinity. For this one, as x approaches 3 from the left on this graph now, coming from the left, we're approaching the y value 2. And as x approaches 3 from the right side, we're actually approaching the same spot, so 2 again. Since the left and the right limits agree, that means the two-sided limit at x equals 3 is also going to be whatever they agreed on, which is 2 in this case. F of 3, that's the value of the function at 3. For that, we look at the solid dot, which happens to be up at the y value 3, so that's actually different than what the graph was approaching, different than the limit. And then as x approaches -infinity, moving to the far left, for y values we're going down forever, so -infinity for the limit, or you could write does not exist, because this is basically does not exist with some direction built in. As we move to the far right with +infinity, we are moving up forever as well, so that means we have a +infinity for our limit for that one. For this whole problem, we're going to use this graph to answer these 6 questions off of limits and function values. So for part A, we're approaching -2 from the left side. So here's -2 for the x value. Approaching from the left side, we're coming down to the y value 0 because we're on the x-axis. As we approach from the right side in part B at x equals -2, we're going to the same place, so that's still 0. So that means the two-sided limit then is going to be 0 because both the left and the right-sided limits agreed on that value. For f of -2, well, that's the solid dot, the function value at -2, which happens to be 3. And next, as x approaches -infinity, as we move to the far left, our graph is going in the upward direction without bound forever. So that means we have +infinity for that limit. And as we move to the far right, we have +infinity for the limit as well, because we're still going up forever. So for both of these, you could say DNE, but +infinity is just a little bit more descriptive.